All right, so again, we are taking notes. I'm sorry I'm not able to be there, but you are still responsible for the notes, understanding the notes, and completing the full assignment for today, which looks to be a maze, okay, where you're going to be showing all your work on different graphs, okay? So you're going to be graphing everything, making sure you understand, okay? So let's get started. Pause this and do the warm-up. A customer paid a total of $6 for 68 copies at a print shop. Some of the copies were black and white, and the rest were colored. Okay, so I know I have two different things. I have black and white. I'm going to label that B, and then I have colors. I'm going to label that C. Okay, so I have something talking about money, and I have another thing talking about copies. Okay, so keeping all that in mind. Each black and white copy costs 8 cents. So I know when I'm talking about money, it'll be 0.08 C, and each color copy costs 15 cents. So 0.15 C. Okay, only when this refers to the money. Write a system of equations going to be used to find B, the number of black and white copies, and C, the number of color copies. All right, so if I have 68 copies in total, my first equation can be B plus C equals 68. And if I spent $6, right, I'm going to use those coefficients, okay, to do my money equation. And those are my two equations. All right, so now let's see what today's lesson is. We're solving systems of equations by graphing. All right, so let's make some observations. How many solutions would you say each of these graphs have? Okay, so if you said one solution, right, for this first one, you were correct, right? It has one solution here at 3, 0. That would be their one solution because they cross one time. If you and your partners discuss that this would have no solutions, you're correct. Why would they have no solutions? Because they would never cross, because these are parallel lines. And then you might be asking yourself, there's only one line I see on this last one. But what if I told you there were two lines? How many solutions then do we have? Infinite solutions. Okay? Because they would be crossing at every single point on this line. Ooh, the skills. Okay, so here's the equations for these lines. Notice there's different slopes here, so that tells you that they were going to cross. Notice there's the same slope here. That's why they never cross. They have different y-intercepts, but the same slope, so they're parallel lines. And then notice on this last one here, the slope is 5/2. Y-intercept is 8. I'm sorry, 4. I was looking at the wrong number. 4. And on this bottom one right here, because I know my little fast trick, the slope is 5/2, and the y-intercept is 4. So it's the same exact equation, right, in different formats. That's why it's the same line. The wonderful thing about if I said this too fast is you can rewind it and replay it. Okay, so please make sure we are utilizing that resource. All right. So we're not going to graph these because we did this last class, so you know how to graph them. Okay, but those notes are there available for you. Okay. So let's do some problems, practice problems. All right. The line graphed on the grid represents the first of two equations. So I know there's a system, more than one equation, and a system of linear equations. So before we keep reading, how about we find all the information we can on this line here, right here, on this grid. So how about we find the slope and we find the y-intercept? Okay, so for one thing I noticed the slope is negative, right, because this line is going down from left to right. I noticed the x and the y-axis are both going by 4s, so I'm going to keep that in mind too. So I see a point here, and I see a point here. I'm going to do my rise over run, rising 4, running 8. So negative 4/8 is the same thing as negative 1/2. And the y-intercept looks to be 10. We're not for sure. We can't say that's for sure the halfway point, but we're just going to use that for the right now. If the graph of the second equation, okay, so for the first equation, I'm going to put this as y1 equals, negative 1/2 x plus 10. So this will represent my first equation. Okay, the second equation, the graph passes through the points negative 12, 20, and 4, 12. Which statement is true? Okay, there's two options here. I can find the equation of these points, or we can just try to graph them on the grid, right? So pause the video, graph these 2 points, plot these 2 points, and connect them, and let's see what you notice about these 2 lines. But I want you to take a step further, find the slope and the y-intercept. Okay, so x1, y1, x2, y2. Go find your slope and y-intercept. Pause the video, do all those things. See if you can come up with your answer with proof. Okay, so hopefully you actually pause the video and you're not just listening in, but I'm going to do 2 ways. I'm going to graph the points and I'm going to connect the lines. Oops. And I'm going to say I notice that I'm pretty sure that these lines are parallel. So I'm going to take it a step further and actually find the slope. So 12 minus 20 over 4 minus negative 12 is 8 over 16, which is, negative 8 over 16, which is negative 1/2. So for this green line, we know the slope is negative 1/2. So we know they don't have the same y-intercept, but we know they have the same slopes. They have the same slopes. So they're parallel lines. Parallel. So will they ever cross? No. So how many solutions do they have? No solutions. Okay, because they'll never cross because they're parallel lines. Okay, now this only works if y'all are actually pausing the video, talking about it amongst each other, okay? So to me, that's the best way to do this when I'm absent. All right. Which graph can be used to find the solution to the system of equations below? 2x plus y equals negative 4, negative 3y equals 2x plus 12. Before I even look at the answer choices, guys, I want to change both of these equations into y equals mx plus b slope-intercept form. So let's start with this first one. 2x plus y equals negative 4. Pause the video, change it to y equals mx plus b. Same thing with the other one. Go change it to y equals mx plus b. And if we're still at the point where we're like, how do I change it to y equals mx plus b? I don't know. You got to understand what I'm saying when I'm saying that, right? We're trying to isolate the y. Okay, so hopefully you paused that video. Okay, so for this equation, I'm going to divide by negative 3 on both sides. Give me y equals negative 2/3 x minus 4. And then for this equation, all I had to do was subtract 2x. And that gave me y equals negative 4 minus 2x. So I want to notice something before I even look at the answer choices. I'm noticing 2 things about these equations. Both equations have a y-intercept of negative 4. And they have different slopes, so I know they're going to cross. And guess where they're going to cross at? The y-intercept, because they have the same y-intercept. So which graph shows both of them having a y-intercept at negative 4? And guys, also remember, you could just graph. Once they're in y equals mx plus b form, you can just go graph it on Desmos, right, too. Okay, but we also have wonderful, amazing brains, okay, that can do this without having to use Desmos. Okay. So we did this last class. So do me a favor, at least do one of these. Go ahead and pause it. Do one of these. And let's see how much you remembered from the previous class period. All right, so hopefully you paused the video. Let's look at it. So we know that this is going to be shaded below. And it's going to be a dashed line. Slope is 2. Y-intercept is negative 4. Okay, so let's go ahead and just do that. Y-intercept is negative 4. slope of 2, dashed line. I don't feel like doing all of these, so we're gonna hopefully get it as straight as possible and shade it below. Okay, and then this one, oops, greater than or equal to is going to be shaded above, and a solid line. Slope is -2/3, y-intercept is 5. Down 2/3, down 2/3, down 2/3. Wait, I did something wrong. Hold on. Down 2/3. There we go. All right. And which way am I shading? Above. So remember that solution is where they're both colored. Okay. So hopefully that was pretty fine. Okay. So on the maze, you were graphing everything, trying to find their solutions. Okay. Y'all are awesome. Do at the end of class. Please do it. Do what you're supposed to be doing. Be leaders. Okay. Y'all are amazing. Bye.